Okay, so we're looking at a projectile that's fired from the ground at a speed here of 25 meters per second, and it's 30 degrees above horizontal. So the first thing that I want to do whenever I read any projectile question is start by breaking up those vectors into their components. So let's see, if we've got a horizontal line here, if a projectile is fired here at 30 degrees, and initial velocity is, what is that, 25 meters per second? We're going to need to break up that vector, that 25 meters per second, into a component that goes horizontal and a component that goes vertical. So here's v1y, here is v1x. We need to find out those two components. So v1, let's start with v1x. v1x is then going to be 25 times the cosine of 30 degrees. And we can work that out, and we'll find v1x is 21.65 meters per second. We need to do the same thing in the y direction. v1y, 25, instead of cosine this time, it's going to be sine, because here you can see it's v1y is opposite the angle, so we're going to use sine. So that's sine of 30 degrees. v1y is 12.5 meters per second. Okay, so we've got v1x, let's put a little box around there, we're going to need that thing. We've got v1y. Oh, and I should say the directions here. This x component is going forwards, so we should stick a little forwards in there, I guess. And the y component here is actually going up. So I should have put that in before. You can see with the arrows up here, the y component is heading up, the x component is heading forwards. Once we've got that, then we're free to start looking in the x and y direction, and we're going to do that separately. So if I look in let's start with the y direction. If I look in the y direction, I'm just going to list off the things that I know. So we always know, the first thing that we always know, acceleration in the y direction, I'll say negative 9.8 meters per second squared. And I'm going to say negative because really I'm saying up is my positive direction. If I know that acceleration, we also know v1y, we just found that out. v1y, 12.5 meters per second. I'm going to keep that as positive because it's up, and up is our positive direction. There's one more thing that we know. It tells us that this projectile is fired from the ground, and that it lands here. It lands back on the ground. So if it starts on the ground and it ends back on the ground, that tells me something about displacement. That tells me that dy is 0. So it starts on the ground, it ends back on the ground. That's a 0 there. Displacement in the y direction is 0. And the thing that I want to solve for in this case is time. And the reason I want time is because time is true. Time is the same, I should say, in both the x and y direction, because time is a scalar, it's not a vector, so it has no direction. I'm going to look through my equation sheet and find a formula that has acceleration v1d and t in it, and it is this guy here, v1t plus 1/2 at squared. That's the best friend equation, affectionately called the best friend equation. We know displacement is 0. We know v1 12.5 times t plus 1/2 negative 9.8 t squared. We can clean this up a little bit. 12.5 t, no change there, but half of 9.8, we can say that's minus 4.9 t squared. We can take that minus 4.9 t squared here, we can take it over to the other side, in which case it becomes positive. So that's going to be 4.9 t squared equals 12.5 t. At this point we can actually cancel a t out. We're really dividing both sides by t. If we do that, it cancels out. We can divide by 4.9 here, divide by 4.9 both sides. What we end up with then is t is 2.55 seconds. That's the time in the y direction, and as I mentioned before, that's also then the time in the x direction. So once we know that, I'm going to come over here and I'm going to say, okay, let's look in the x direction. So here's the x direction. And again, to list all the things I know in the x direction, I always know acceleration in the x direction is always 0. That is always true. We also found way back at the beginning, way back over here, we found v1x was 21.65. So I'm going to write that again. v1x 21.65 meters per second. The equation that I have in the x direction is really always the same. Because acceleration is 0, if you think of that best friend equation, and here I'll point to it again in the y direction, this best friend equation right here, if acceleration is 0, then that whole thing goes away. So if I write it again here, d is v1t plus 1/2 at squared. Because acceleration is 0, 0 times anything over here is 0. That whole thing goes away. What I'm left with always in the x direction is just distance is v1 times t. And that v1 really is the same as v2. Because acceleration is 0, v1x is equal to v2x. I could just say distance is v times t. Distance then, v1, again, we found that was 21.65. The time that we found, again, over here, we found it in the y direction. That same time is going to be true up here. So the time here, the time here is, can't get rid of that line. The time here is 2.55. That's 2.55 there. When I multiply those two things, I'll come down here to skip that line I can't seem to get rid of. The distance here, 55.2 meters. We want to round that for significant digits. We kind of have 2 sig digs in the question, so I'm going to stick with 2 sig digs in my answer. And there is kind of the final answer. The question originally was, how far away does it land back on the ground? Here's the answer. It lands 55 meters away on the ground.